So we have everybody from music and history and sociology, liberal arts, foreign language, whatever it is, those people come in and they do fine. Start from the beginning. Yeah, they're very successful. Sometimes coming with a clean slate is kind of an advantage.
Hello, everybody, and welcome to another amazing episode of Edu Unlocked, where we meet with inspirational leaders from higher education, leaders in enrollment, leaders in technology, leaders who are helping shape institutions globally. Today, we have another special guest with us, somebody who's helped shape the world of data science and machine learning in some ways possible. We have Dr. Brian Wright with us, who's the Associate Professor of Data Science at the University of Virginia's School of Data Science. Dr. Wright, welcome to our podcast.
All right, yeah, happy to be here. It's a lot of pressure. I hope I live up to the that introduction. Thanks.
Yeah. No, well, there's more coming in terms of introduction.
Oh no, okay, all right,
preparation.
Yeah. Okay, good. Yeah,
but I want to let our listeners know that Dr. Wright is not just someone who thinks data science, but he also he designs curriculum. Like, he's helped shape the university's data science curriculum, and I want to talk about that a little bit. What goes into your thought process, right? We'll talk about that because that's a field that keeps changing. But other than University of Virginia, you've played a pivotal role also in the Masters in Data Science program at George Washington. You've co-founded the Data Science Institute there. That's pretty amazing. You've done some work for the Department of Defense, and you hold a Ph.D. in higher education administration. So you actually you don't just think data science and how those things should operate for the workforce, for students, but you also you take an active role in administration, and that's amazing. Would love to chat with you on that today.
Great, happy to do it. Yeah, thanks again for having me, and
fantastic.
I look forward to it. Yeah.
So talk to us, Dr. Wright, about the data science program at Virginia. Like, what's special about it, and what got you to design that program, and what you said you thought were like your secret sauce, that you put in?
Yeah, okay. Well, UVA's Data Science School, the School of Data Science, was the first one in the country. No big deal. But it
big deal.
As a result, because humble brag. But as a result of that, it gave us a lot of aperture to say to ourselves, all right, so if we're going to set a line in the sand here, we're going to create this first school, like what does data science mean to us? Like, what does it actually represent in terms of the body of knowledge, in terms of what we want to manifest inside our programs? And so that's the first thing we did. And that was, around 2019. There's just a small group of us. I don't want to go back too much in the Wayback Machine here, but after I left GW and then came to UVA, I mean, I only had like 4 or 5 faculty. I mean, it was a small group, smaller than most departments. It's still not super big now. We have 30. But, some of the early faculty that were here, Rafael Zarado and Don Brown and myself and others, John Kropko, we sat down and we said, okay, let's frame out the space. And we came up with I don't want to get into the details of it, but we came up with like a 4+1 model, which kind of like represents these different areas of the field. And we designed all our curriculum basically as using that as a framework. And so if there is secret sauce, I mean, that's probably it, so the 4 spaces, I mean, generally it's kind of like value and ethics, right? We have design, which is about communicating data, organizing, designing data projects. And then we have systems, which is like all the engineering, like DevOps, like deployment, also coding, programming, cloud computing, and then analytics, which is machine learning. And then kind of at the middle is like the practice of data science. And so a lot of these features were already present, like in the market, in terms of the way that data science programs were coming up, but nobody really leaned into saying, you need to have each of these in balance and in proportion to have like, this is what we want graduates to know. So that's what we did. And which I think you couldn't really do unless you had, kind of this space to do it, like in your own school or like your own department. And so we had to build all our own classes, hire our own faculty. And so it was a real luxury to be able to go through that.
And I'm guessing hiring faculty must have been tough because, I mean, we're talking first data science program in the country.
That's right. Well, Well, right. So it was the first school, right? So there's lots of programs out there, but it was the first one was a standalone school. And
Yeah, yeah, that's true. Yeah.
yeah, and even for this year, in the first couple of years, we focused a lot on not hiring as much faculty, but as much as building kind of like the actual administrative kind of organization, right? So we need everybody from HR to communications to, just admissions, student affairs, like a lot of that stuff had to be in place. So we did a bunch of that. And then the last 3 years, I'd say, we've just been pretty much, it feels like a whole nother job. It's just hiring faculty all all the time. We're searching for another 12 this year, which is a huge
Oh, wow.
number. Yeah, for a school. And we've done that pretty consistently year over year. It's about that number. Yeah.
That's amazing. What
Yeah.
got you into this, Dr. Wright? Was this a plan all along, or you
Oh,
stumbled on something and you said, "Oh, this looks like a less riskier path for me"? Like, talk to us
yeah.
a little bit about your career path.
Yeah, I don't know. It's a wandering road. I think like most people, like I had ideals. I think that drove my journey. I was always very, I wanted to work on something that I could put my heart into, to be honest. Like I was like a bit of a mission focused. And to be honest, it's why I was like at the DoD. I mean, it felt that way, kind of working towards, the mission of the country and the DoD was great. It ended up being not a place where you could like dynamically improve like very fast. And that's kind of like
Hmm.
typical of most places. So I jumped and did consulting, but I stayed in the federal government. I was in the chairman of the Joint Chiefs for like 3 years, and that was moving really fast, and it was great. And the consulting side of it literally allowed you to kind of build yourself up. But then over time, it became like I was trying to get out of DC actually because of just like the pace of life. And so I went back to my alma mater. I did everything at the University of Tennessee. And I helped stand up a research institute in the business school there that was in the statistics and logistics department. And people know, maybe some people do, some people don't, but Tennessee has one of the best logistics programs in the country. For a while, is rated number one, and that's all about like kind of applied statistics. And so
Hmm.
that's where like we started doing a ton of like applied statistical modeling. We're using some machine learning algorithms, all sponsored really from the Air Force because it had kind of like this flavor of like kind of a defense institute. And I did my PhD at night. So I worked with faculty in those departments on research teams from economics and statistics during the day. And then I was like doing PhD stuff at night. And so that's where I really learned like all my data science chops. I have an
Hmm.
economics degree, so I had like a foundation in these quantitative methods, but the applied part of it, like solving problems, that's pretty much all we did, like for 3 years, which was awesome.
And
Um,
and then you get hooked onto it, and then you're like, okay, instead of running a million rows on spreadsheets and then having it
yeah,
stall on you, you
yeah.
just you learn new methods of working on that data, and then that's what.
That's right.
Yeah,
And it's right about the same time the market started going crazy. So I was
yeah,
there in like 2010,
yeah. So big
2011. You get
data.
that
Yeah,
right. Harvard piece comes out. It's the sexiest job in the 21st century is to be
yeah.
statistician, data scientist, and then it just went nuts. So I got married, and then we went back to DC because that's where our families were from. And so my wife and I, we started our careers there, and I wanted to stay in education. So I got a job at GW. And one of the first things they asked me to do was like help out with the data science program and build it out. And I was like, sure. And so
Yeah, absolutely.
we did so well. I ended up going over and being faculty there. And then I've just been in it. I've been in it ever since. Yeah.
That's amazing.
Yeah.
What's your, so it's, would you say there was a little bit of a career change along the way?
Yeah. I mean,
Yeah.
depending on the fidelity there, I might say that this is like my third or fourth career. Being a federal employee is much different than being a consultant, even though I was working in the same market. So it's kind of like a career shift, but maybe not really. And
Okay, yeah.
then, I was really working as a researcher pretty much primarily. Like when I was at Tennessee, I was teaching some classes, but not quite as much. But when I got to GW, it was like another kind of like a bit of a, in the same market, but a change where I was really teaching, kind of full time, a lot of teaching, a lot of classes, which was different, something I had not done in the past. And that's what really, I mean, that part of it I just ended up loving, so I just wanted to do that as much as possible.
How easy do you think it is for somebody who's in higher ed, like working, let's say, in something in academics or other
Yeah.
administrative roles? to suddenly say, yeah, I'm going to look at technology. I'm going to start thinking about business analytics or data science or things like that, because that's the future.
Yeah.
It can probably make me a little more money. Like, what's your feedback there?
I think it's totally possible. I mean, I think it's more easier now than it kind of ever has been. I mean, there's so many. I mean, there's high quality like non-accredited like outside of school programs that you can take will get you a long way. I mean, like IBM, like Google, they have their own classes. They're good. The stuff that's on Coursera or edX. Like if you didn't want to go full academic program, you just wanted to pick up some skills and apply it inside your job. Like it's it, and you make a hard argument that those are just as good as maybe some of the accredited programs nowadays. I mean, they're good.
Hmm.
And a
I
lot of
mean,
that stuff
yeah.
wasn't even present really when I was starting to pick up a bunch of this stuff. Yeah.
Exactly what I was gonna say is
Yeah.
there's so much coming every time. Like, we last time we spoke, we talked about like LLMs, and it's just
Right.
the
Yeah.
person who knows the most about it is probably like has like 2 years or 3 years of knowledge on it.
That's right. Yeah. Yeah, that's totally fair. I mean, the pace of technology innovation now is I mean, it's our job. I mean, in large part, our job to like try and stay up with like all these methods. Because as you're researching and like creating projects or delivering curriculum in the classroom, you want to stay right there. But it is so much harder now, even than it was just a couple of years ago. I mean, the pace of change is really
Yeah.
fast. And so sometimes it's another reason why, some of the online platforms, they may respond even quicker than we do in academia. But again, I think it's totally possible to pick that up. And we have our own like large language model research group, that I have an active learning lab. So we're building intelligent agents and putting them into classrooms and then trying to track and see how students are using them or how to be honest, how really brittle they are, like how hard they are to train and fine tune to make sure that you can get consistent results. I think it's still an open question, to be honest.
Yeah, yeah. And I
So
was going
yeah,
to talk about that. I mean, the theme I think here is there are listeners who are in higher ed who are looking for leadership roles, but we're also
yeah,
looking for transitions and what should they be doing next. So I think
sure.
that definitely helps learning from you on uh, just based on your career trajectory, that it's if you want to switch to something that that's in technology and you've not done it before ever, it doesn't mean you have to have had a bachelor's in computer science at least. No, you just like these are
I don't
things
think
today
so.
you can learn even on the internet. Yeah.
I mean, to be clear, I mean, most of the students that are in our graduate level programs, they don't come from those backgrounds. I mean, there is something we can offer. I mean, our degree is kind of a career transition degree, the one we offer here, which is very typical of a lot of data science degrees. And so we have everybody from music and history and sociology, liberal arts, foreign language, whatever it is, those people come in and they do fine.
They do
You kind of
fine.
start
Yeah.
from the beginning. Yeah, they're very successful. Sometimes coming with a clean slate is kind of an advantage, to be honest. So I
No
mean, in some
prejudice.
ways,
Yeah,
yeah, you don't
right.
have any prejudice. I mean, for some of the people that come from stats or from computer science, I mean, sometimes it's hard to kind of they have to translate what they've learned in the past to what we're showing them now. That
Yeah.
translation effect can take can take energy.
That is
And
true. That is, yeah, that's a
yeah,
very good point. Yeah, yeah. I mean, I did my bachelor's and master's in biotech, and I'm running a tech
wow,
company now.
there you go.
We deal with machine learning and AI stuff all day, all night.
Yeah,
But I don't I didn't ever feel there was a gap that I needed a computer science degree or something to fill in. There's so much you can learn just by getting on the internet. It's crazy. Yeah.
definitely. Yeah.
So talking about LLMs, now that we're on that topic, that's
Oh
one
yeah.
of like your favorite subjects. You touched upon it last time. You're
Yeah.
very intrigued by where they're going. So do you think we're ever going to have a Bank of America bot or a Booking.com bot where we actually don't have to say, hey, I want to talk to an agent?
I was doing this work directly, but through a colleague of mine who runs, is the head of an AI research, group here. They're designing some of these, and part of his job is just to break the large language models. He's a red team. His research team is basically the red team before go live. So people will build prototypes. They come to him, and they break them like a lot.
Mm,
Just through compression testing, so you can just fire off, basically train one AI bot to like attack the other one. through a series of prompts, right? So it might be they're answering thousands and thousands of progressive questions, but eventually that large language model gives you something it shouldn't. It gives you like movie
Yeah.
quote, or it says, hey, put your money in Bitcoin. You're like, okay, you have to be careful. So you
Uh-huh.
can, as many guardrails as you want to put in place, that I think especially for organizations that are like heavily risk averse, like large language models is a bad choice. I mean, they do something simpler. Like if there's a real problem there, like they're losing customers because the chatbot just isn't authentic enough. Like, okay, that's usually not the case. Usually it's a feature, not actually it's not derivative of the entire business model. So then it's really a question of how much risk you want to put into this feature, maybe not much.
Yeah.
But I think like the memory loss problem, associated with like how quickly like they atrophy in terms of like their the responses that are high quality over time is still a problem.
Hmm.
RAG distributions, distilled large language models, like controlling the embedding spaces, like these work, like prompt educate, like all these things work. There are arbitrages against that like problem, but it's still an organic feature. Like it's still, so
Yeah.
you have to guard against. So like it's still there. And then you lose some of the niceties of like traditional, word to vec, where it's like, king to queen is to prince to princess. That doesn't
Mm.
exist in large
Mm.
language models. So they have these empirical features that aren't there because of the size of them. So they the nature of the how quickly they respond to prompts and stuff, it means that they have to kind of push everything outward.
Mm.
And
Hmm.
so the embedding spaces becomes kind of just on the surface. So you don't
That's
have a lot of
interesting.
cool
So
features. Yeah.
talking about that, I mean, do you think, like when Wikipedia started, we said, oh my God, it's going to be at some point the largest like encyclopedia of information and everything. And then
Yeah.
they could never solve the problem of fake information on Wikipedia because I could launch a page on myself and write
Sorry.
whatever I want.
Yeah.
And it's hard to get it peer reviewed or do that kind of stuff. So do you think the
Yeah.
fact that LLMs like ChatGPT actually learn from all the information that's out there, and those, so that whole challenge of hallucination, which now they claim in the next version it's gonna be completely gone. But do you think all that is even
Mhm.
possible, considering
Yeah.
that like so much of the information that it's learning from, its training data, it actually has non-factual information in it?
Yeah. It's weird because I don't think you can think of large language models as a data store. Like, I just don't think that's the way I think if you approach it that way, you're destined for failure, and I mean, the
Mm-hmm.
quality of like these AI generated search responses, like on top of your browsers and stuff, like they're kind of good, but like, is it better than just a traditional, like, I don't know, vector-based keyword, prompt? I don't know. I I think if we think of it as like, and maybe an analogy is that, when we're all learning to read, right? And you can become a proficient reader like at what age? Like in maybe 10th or 11th grade, maybe onward after that. I think we have to think of like these foundation models as like proficient readers. Like they understand like uh, language, and they can respond to it. But just like a 12th grader, they don't know everything, right? And
Mm-hmm.
so like you can't just because you can read and write doesn't mean you have a capacity of knowledge. And I mean, maybe it's a loose analogy, but if you use it like that, like a an intelligent foundation with which you can then build something on top, I think the conversation works much better. If you use it as simply a prompt recall type of, I don't know, to me that it doesn't work as well. And I think that's why it works really well for like editing or like idea iteration or like outlines or summaries, because you provided the information it needs. It understands the language and it can give it back to you in a way that you want it to, right? Which is an ideal use case as
Yeah.
compared to building it into some application that must generate new information or timely information. Like, you're destined for failure. I mean, even if it
Mm.
doesn't hallucinate, like, I get it, but it doesn't understand meaning. Like, it just doesn't. Like, there's no meaning there as much as people want it to be. If you look at them underneath the hood empirically, I mean, it doesn't. It uses the distribution hypothesis, right? That words that are close together mean something, and it does work, but it doesn't mean that it understands the words that it's producing back. Yeah.
Interesting thought there. Yeah, I mean, I'm really looking forward to see where it can go, because it
Yeah.
seems to me like it has the ability to make, like science we've had this in science fiction for a while, where there's this
Yeah,
assistant in your ear all the time who knows so much
sure.
about you. And it kind of felt when ChatGPT launched the latest like 4.0. I've been using it a lot. Like when I'm walking my dog, I'm talking to it just to kind of see where
Sure.
it's at. And it's actually kind of amazing, like
Yeah.
where it's at, right?
Yeah, no, I don't
Yeah.
disagree. It is a total technology breakthrough. Like I'm saying when on the future, I think they're going to be, interesting. I think the multimodal aspect of it, I think is going to be, I think there's a lot left to know about like if
Sure.
how the combination of voice and image and sound and text together, like those things, I think that's a very interesting prospect. I mean, the continuous learning aspect of it is really cool too, that you can create AI agents on top of the models and they just continue to learn over time. I think that's a good one, almost like an intern, you embed them into your team and it gets to know you more and more because it understands language. You can speak to it in a common language.
Hmm.
And there's been some interesting, back and discussions, I would say, and people that are closer to this as it relates to like low density languages where there's not a lot of text, like how to train agents using English to translate and basically relying on experts to kind of continuously have conversations over
Mhm.
time. And that creates a database that actually can be used as more of a repository for training and what that looks like. So I think yeah, we're certainly just getting started, right? I mean, like you said, an expert might be 4 or 5 years, worth of experience or something. So we're just getting started, and it's cool the progress it's making, and it seems like every week there's a new paper with a new breakthrough, that allows you to think about these things differently. So
Absolutely, yeah.
yeah,
And coming to students, so we have some of our listeners are students
ah,
who always want to think about whether they're on the right track, right? Every student, when we were students, we were paranoid too. Am I picking the right course, the right degree? Will I get the right job?
yeah,
You seem to have been someone who's adapted to changing times, right? You moved into data science. You've now
sure,
got into like trying to understand LLMs. That's the newest thing, and you're like, oh, I'm intrigued. And you're comparing it to legacy systems, like, oh yeah, this is how word to work. I love it.
yeah,
In terms of students who are thinking about, what whether data science is right, it kind of feels like that that article that came out about data science being the number one job no more like
yeah,
stands
yeah,
true. Now there's newer things. What trajectory do you see the world progressing in, and what would be your
yeah.
suggestion and advice to those students who are starting out?
Well, again, I'll say this from, I am of course biased, but I think that the way that we've positioned our undergraduate degree is, and that we've advertised and talked about it, is that it's a liberal arts degree for the data age, right? It's not a liberal arts degree, but you can think of it as like, a foundational knowledge for the 21st century. I mean, computer science, you make the argument it's the same, there are advantages there for traditional kind of software development skills are always going to be kind of, present. But the really interesting
Yeah.
part about the data science aspect of it, this is true of other fields as well, is that you can take those skills and then go into and
Apply.
basically every market vertical, right? Or every kind of
Sure.
area. And then that could be a whole career, the way you think about it, just learning and understanding how they use data in that particular space. The methodologies and the techniques
Maybe.
totally translate, right? But
Yeah.
it's the field that can
The
make the
field.
difference.
Yeah.
And
Yeah.
so to me, I just I can't see getting a data science degree as being a bad choice. The way I think of it is like now, especially with like the knowledge economy and like, what the typical working kind of, education level is that you think of yourself as getting this like well-rounded, kind of foundation in data science skills, right? Which includes like, lots of things that are heavily marketable, which can allow you to go right into the market. But then you can also think about, well, what domain area could I bolt on top of this? Like maybe in the
Mhm.
future, like in public health or in, who knows what else, in GIS or in finance or whatever. And so, there's ways where it allows you to, or law. I mean, we have a ton of students that are very interested in going into law. And the Justice Department last year changed or the year before, they changed their like summer internship program where they weren't hiring pre-law or economics. They were only hiring data analysts, which was like a big demand signal for like where they thought the field was going to go. So they're bringing in all these data analyst majors into the Justice Department to help them manage their, their projects. And so I think of it as that way. It's just like you just can't miss kind of foundation. And
Yeah.
then you can make the choice about where you want to go. And the last part I'll say is that we actually built that into the degree. So we have 9 concentrations in different areas, everything from public policy and leadership, from economics to accounting to public health, neuroscience, astrophysics. Like we have all of these concentrations that are part of the degree that the students, once they get through our core, then they just jump in to a concentration. They can, and maybe do many of
Oh,
them,
so
which is
you're
really cool.
saying you're
Yeah.
part of the data science program, and then you can concentrate in neuroscience when then you're learning more about clinical data, clinical
Yeah.
research data, all of that kind of stuff.
Yeah, that's
Oh,
exactly right.
yeah.
Yeah. And then the idea is that, and this was designed by the faculty from those departments, is that they wanted students to take a few of the courses because they're going to come with these data science, machine learning skills, take a few entry-level courses. So they'll be conversational in that field, and then they can take them and put them into their lab groups. So that's a combination of like this basic understanding of the field and then also like 2.5 years of data, you know, curriculum. It'd be pretty valuable. Yeah.
I love it. Yeah, that's amazing. And I was expecting you would say that, because I do agree, and I feel the same way. As I mean, even when you're thinking machine learning, AI, core data science skills always are of prime importance.
Yeah.
Yeah, I mean, there's a lot of abstraction that companies like AWS and Google Cloud and all of them are doing, where now you can take all of your data and just magically like just bump it against a model, and it
Yeah.
spits back some result. But
Yeah.
understanding the core of that, understanding how data actually works, yeah, that's super important. So we're
Yeah.
always looking for data science graduates still, even if we're hiring
Good.
machine learning engineers or anybody else. So this
Yeah.
is good.
Yeah. Well, let me know. I got a small army. They're all coming out. But yeah,
I'll let you help me make the pick. That'll
there
make
you go.
my interview process easy.
There you go. Yeah, I'm happy to do that. Yeah,
Uh,
I think it's fun. And then the nice part about our degrees and many of the other ones is that it really does center on like this, on solving problems, so it's like the thing that the students that we try and give them over and over again is this like intuition about the way things are going to work out. Like you can develop intuition through like practice over time. And so even, people that are just like dumping their data into Google spreadsheets or into some type of AI cloud system, like the hard part is like where do those instincts get developed that help facilitate like how they should use those results. And it ends up, even if it's like hard quantitative people, typically the people that are best at their jobs are the ones that are like can see the mistakes coming, and that's because they made them before,
yeah,
and so that part of it is tough, and it takes a little while to get there for that, but usually that's the
yeah.
thing that puts people over top is just kind of this general experience, and that's what we're hoping to get like with the concentration, so they can kind of do more projects and develop that muscle a bit. Yeah.
But do you think, like a few decades from now, let's say, we will lose that intuition around learning around data, because now that we're developing all these large machine learning models that can do so much of the thinking themselves? I mean, now you have
Yeah.
machines writing code. They can write an entire piece of software themselves.
Ugh.
How
Yeah.
how do you think that's going to shape us as humans who think? And what does the data science program become 20 years from now?
Well, 20 years is hard because it's like, I don't know. The way that technology is moving now, like no one can predict, like what's going to happen, but there are these, what we do know is like if you consider trend lines, the way things are going, like the emphasis and the need and the way that companies across the spectrum are using and leveraging data as like a just normative strategic advantage or strategic like requirement keeps going up. Like if you're not doing that, then you're gonna have market failure, right? I mean, it just the advantage of being able to do that is so important that that demand doesn't feel like it's going anywhere. Now, I do think like the automation is going to definitely be like a real thing, and a lot of the code production, like again, it's compared to, and not to anyway, it's compared to someone that's just strictly, like you said, developing pure suites of pure scripts of software for deployment. Data scientists, kind of hacky coders, because the idea is like we're not necessarily developing a full stand-up piece of software. We're
Hmm.
leveraging the tools in order to be able to solve some problem, and to a certain extent, if like that automation of that, like getting to the point where you can iterate, like discover, iterate, discover, iterate, discover gets easier, then that's great. You're moving, from a typewriter to a word processor, like and further up. And we already embed, all the AI machines into into our courses. It's almost impossible not to, especially if you're using like VS Code, where it's just like
Right.
organically embedded. Uh, Copilot is just there and it works really well. And so the hard part about that, at least in our experience, I think, I don't know, and this is a generalization, but once you get over a certain amount of lines in the code, at least relative to the things that we're doing, the code generator starts to kind of break down. And so, in some ways, like what it demands that you do is break down your problem into smaller pieces and then solve each piece. And if the code generator is creating you code for that little piece, that's fine. I mean,
Mm.
to me, I don't think it really matters. You're going to be exposed to code so much and doing it, like you almost have to ignore it not to really understand it. And so, in some ways, it almost encourages students to think more strategically about the things they're doing, as compared to usually the instinct is to just jump in and start coding right away without really thinking about what are the things you need to solve in what order. And because the limitations, kind of, this is not always true, but because of the limitations of some of the things that Google with Copilot can do, it actually sometimes helps, because they have to
Mm.
stop and be like, okay, this is too much script. Like, I don't really understand what's going on here. And they have to go back, create smaller problems and solve those and then move to the next, which is
Yeah.
exactly what we want them to do, is that iteration is the point. Yeah. So
Love
I
it.
don't know, 20 years from
Yeah.
now, I can't answer. I don't know. I'll probably,
Yeah. Yeah,
well,
it's hard at this
yeah.
point. It's hard to
Yeah.
answer what's going to happen 3 years from now. It's
Yeah,
just
that's right. 3 months. Like, I don't know. I don't know. Yeah.
yeah.
It's crazy. But I do agree
Uh-huh.
with you. I think that 100%, like whatever we're doing now is not what we'll be doing. Like even a few years from now, things will change so fast. I'm sure of it. Which is part of the reason I like the field so much, because it's a real challenge. I mean, if you want to stay in
Yep.
it, you really do. I mean, if you step out of that stream, even for a little while, like the cost is expensive to get back up.
Yeah,
And
and
so,
you can get
yeah,
irrelevant pretty quickly if you
pretty
go on a
fast.
vacation for a couple of months and you're irrelevant
That's right.
at this point.
Come back. Sorry, you've been replaced. Like, oh, uh, yeah. Like
Yeah.
I said, I think some of these things like experience and intuition really do like that becomes like. But if you're not using the latest tools to drive that, then that's
Yes.
also a problem.
Bringing all that together, you speak about blurring the lines between institution and the workforce,
Yeah.
right? And that's what you're aiming to do with the program there. You're looking at the latest, greatest technologies. You're working on LLMs. So, uh, how successful do you think you are at being able to blur that line? Because that's something that a lot of institutions are in the hunt for, right? And it's just
Yeah.
hard for them to cope up with the pace of technology, pace of the industry.
I will say it's a challenge. And I think there's some cultural stuff around what it means to be a faculty member that makes it hard.
Hmm.
Because there are things about being a kind of a more seasoned faculty member that are normalized, that we're in our jobs for a long
Hmm.
time, that the experience plays. But having about again being able to hire so many people in the school, we have a ton of younger faculty. And the nice part about that is that often they teach up. If you have a community where someone's been here for a while, they're really good at a certain thing, but like you said, maybe they stepped out of the stream for a little bit. Like we can organically, at least right now, because of the youth of the school, like cross-pollinate that in a pretty healthy way. Like from my experience, this
Mm.
is like the best way to do your research program, to like teach in a class, like fundamentals. And then it goes the other way. And they're like, well, I'm using this really innovative way, this technique, this tool, this approach that maybe you hadn't thought about because you've been using, our studio for the last 15 years. So like it's nice. So it like kind of it evolves both ways. we also try and like whatever possible, like the motto of the school is like the school without walls, is to try and bring industry in because
Hmm.
it's not if you accept the reality that industry is going to be ahead of you, and they probably will. They almost at least in data science, I don't see a frontier where they're not like at least equal or running ahead, just given how fast they can move. um, and try and leverage that not as a weakness, but as like an asset. That you have this population of people out there that maybe they graduated from UVA, they're really into data science, they want a space to work, they like being around students, like just own that and bring it in. I think a lot of schools are doing that, and we're doing that too. So we have a I have a group of just like pure data scientists, like 3 or 4 years out of school or less, that are our curriculum advisory group that advise the undergraduate program. So they're either graduates from our program or just colleagues I've met that are just they're keyboard, they're doing the work, and that's the level that you want, to like really understand like what is the latest thing. And so I bring
Yeah.
them in every semester and just ask questions like where are we at? Are we keeping up? And it helps. So yeah.
Mm. Not meaning to be controversial here, but
Oh, yeah,
would
please
you
do.
would you rather prefer dealing with a human or a machine? And would that preference change based on certain things you want to do, achieve?
Yeah.
Where are you at with that?
That's a good question. So it certainly depends on the context. That there are certain things where if you just need an answer fast, I mean, geez, it's so much easier just to have a nice machine that could search and bring that answer for you instead of having to rely on humans to respond or pinging or being or whatever like social dynamics happen to be present, right? If things are complicated, if there is history involved and there are personalities involved, then of course it's better, to have, humans there as much as possible. I think the complexity of any situation, kind of dictates like where you fall on that. I will say like
Mm.
we're like we're working on an intelligent agent to embed, and I've done it in other classes, but into our machine introduction to machine learning class as a as almost like a just like a study buddy or like a tutor or like a reference agent, like all those things, like not one that'll like generate questions for you and like you can rep on it, but one will be like, okay, that's located in lab 7, and also by the way it's in chapter 3 of the book that Brian recommended, like that, like tailored towards the content in our class. And part of that project is what we're exploring is like embedding that agent. Like, how does that change like the dynamics associated with just the interaction between like student, TA, and teacher? Like what you can think of it as like in a traditional kind of model where you have like your like um, you know on-prem like bought IT system, which is like Blackboard or Canvas or whatever. So there's that. So they interact with that, and email is part of that. So there's a technology layer that's on the outside, but inside the team, there's these natural interactions that typically occur between like
Hmm.
professor and student and TA. So what happens when you drop an intelligent agent in there? Like, do they leverage that more? Like, do they leverage it between hours of 10 and 3 a.m. when I'm not going to answer emails, right? But they can do that because that might be when they study, I don't know.
Exactly.
And
Yeah.
and then how does it work when they're just in a team by themselves? Like work because we do everything's active learning, right? So they're like a team. Do they pull up the agent as a reference point to go back and forth about it? So I'm interested in the quality of the agent responses, like that's an important part of it. But the more interesting part, I think that we can solve that problem is like how it actually changes the dynamics in the classroom in these like microcosm uh little teams
Mm.
and the communications between the different players. So I think that
Yeah.
part of it kind of gets to where you're like what they might there's some students that might totally prefer not to talk to the teacher or
For
the
sure.
TA, right? They go straight to the agent. Why not? It might be more efficient, like you said, all the reasons. Yeah.
I was very intrigued at the latest Tesla event where they were showing those robo taxis, but then there were a bunch of like humanoid machines that walked out, and I was
Yeah.
like blurring the lines between a machine and a human.
Yeah.
was very, very interesting for me to see. I didn't expect that in 2024, but that was interesting. So, the pace of just even blurring the lines between a human and machine, like once
Yeah.
we get to a point where you're talking to a machine, but you cannot really identify whether it's a machine or a human, we're kind of close to that, I feel.
Yeah, that's the Turing test, right? You just can't tell the difference. And so yeah,
Yeah.
I agree. Yeah, so we'll see. And then it's if you know or don't know, like that is a condition. But if you know, do you make the same choices? Like that's also a condition like worth exploring. Like it's interesting to see. And there's a bunch of, then it gets into, trustworthy AI and like how you build explainable
Mhm.
systems or trustworthy systems that people can rely on, things like that. And that's a field that's going to grow and grow exponentially,
Yeah,
certainly. Yeah.
amazing. Well, Dr. Wright, thank you so much for sharing all that information. I'm
Sure.
hoping this will be helpful to students who are thinking about the future. This will be helpful to faculty and administrators who are thinking about, hey, I want to get a flavor of technology in my life because everybody is out there doing technology, and with all these LLMs and AI
Yeah.
and machine learning, I'm kind of left out. So I think you're like a guiding light to those kind of people in terms of getting in that direction. So thank you so much for sharing all those
Sure.
insights.
Yeah. Happy to do it. It was a lot of fun. And yeah, if anybody wants to reach out or has questions, feel free to just shoot me an email if they want. It's Brian Wright at virginia.edu. I'm always happy to chat or talk if people want some advice.
Amazing.
So,
Thank you so much. We'll make sure we add that email to our description and people can
very
reach
good.
out.
Okay.
So that'll help. But thank you. And thank you to our listeners for joining another episode of Edu Unlocked with me, Ashish Fernando, and our special guest for today, Dr. Brian Wright from UVA. Thank you, everybody.